Okay, good morning, everyone. I want to welcome everybody to our webinar today. My name is David Zabka. I am the Western Territory Manager here with SDS2. Have with me today somebody from CoreBrace. I'll let him do his own introduction here.
Yeah, my name is Brant Saxe. I'm the Technical Director at CoreBrace out here in Salt Lake City, Utah. So glad to be here today.
All right, yep. So just a quick introduction here and what's going on. So I've been working with CoreBrace here for quite a while now. We both saw a need for some integration between SDS2 detailing and CoreBrace with all the coordination that they do on their side of things between them and the detailers. So I think this is going to make a lot of people happy. Have a lot of people that are already excited about this. So be some good stuff here. So Brant today is going to discuss a little bit up front, kind of what CoreBrace is, how that works, what purpose it serves in the steel construction industry. And once he's done with that, I'm going to kind of go through what the process of coordination looks like between SDS or a detailer and CoreBrace. And then I'll walk through kind of what that looks like today with the integration that we've done and how that can help us out. So we'll hop into it here. I'm going to let Brant kind of take over. We have a slide here to begin off with a video. So Brant, go ahead and take it away.
Great. So yeah, thanks everybody for being here. It's real good to be with you. The video that's showing is a test that was done down in the outdoor shake table at UC San Diego. It's a big 2-story building. It's got a bunch of mass, steel and concrete plates and added to it to give it a mass, and then the ground, the shake table shakes and kind of produces an earthquake motion. The diagonal member there with the big A on it is the buckling restrained brace. That's actually the casing of the brace, but if you look right there around that A, you can kind of see the relative movement that's happening between the rest of the brace and that casing. The core plate of the BRB is the element that's kind of underneath that blue gauge that's on there near the A. That member runs from end to end of the brace and connects the gusset at the top and the bottom of the brace. And it's really this whole BRB element that is resisting the earthquake motion and keeping the building standing up. And it's dissipating that energy so that it's working it out of the system. On our next slide here, there's a kind of an exploded view of the BRB here on the left. That gray member is the casing that we just saw that had the big A on it, and the red element that's shown there is the core plate that's running from end to end, and it's got some specifics on the inside of the casing that make it able to stretch and compress and stretch and compress over and over and over again. And this is, like I said, the element that's dissipating all of this earthquake energy, and it can generally dissipate many earthquakes worth of energy. So you could BRB and could really be left in place for many earthquakes. But this ability to dissipate all the earthquake energy leads to dramatically improved performance for the building in an earthquake. So that's kind of one of the secrets and one of the real benefits of the BRB. Then the blue elements that are shown there are kind of the connecting elements, and they're kind of what we're going to be talking a lot about today, but that's kind of how we interface with the structure. On the right of the slide here are 2 frame elevations of a building, and this was designed twice by the engineer, once with BRBs, they're shown on the left, and once with kind of more traditional brace frame. And so looking at that, you can see, say at the bottom level, for example, on the traditional brace that's labeled OCBF there, ordinary concentric brace frame, you got 503 pound per foot beams, and on the right, excuse me, on the BRB frame on the left, you've got 77 pound per foot beams. And similarly, you've got 600 pound per foot columns, and the BRB frame's got 340 pound per foot columns. So there's also a dramatic weight and material savings, and therefore a cost saving that the structure can gain. So you get a performance savings and a cost savings, which is kind of the holy grail, and is really what we do as construction professionals. We over time, we find ways to do things smarter, and that's exactly what a BRB is. We found a way to tackle this problem of handling earthquakes smarter than maybe what was done in the past. And because of this, we all have to think a tiny bit more about the design of the BRB and how it's put together, and then how it's put into the structure. And that's a little bit of what we're talking about today.
So
go ahead.
Grant, if I can interrupt, a question that I get a lot from people is, is the CoreBrace, is it filled with concrete? Is that correct? And if so, what's the purpose of that?
Yeah, and so I didn't know how much to bore everyone today, and so I skimmed it, but it is the inside of that casing is filled with concrete almost all the way to the core plate, but there's a tiny little gap that's left so that the core plate is not composite with the casing. If you thought about a really thin wire, for example, and you pushed on the end of it, it would just bend. If you put that wire inside of a pipe and you pushed on it, it would bend only until it hit the edge of the pipe. And then all of a sudden you get into second and third and fourth mode buckling, and it becomes very strong. So that the concrete acts effectively to remove the empty spaces in the casing. And so the BRB the core plate will bend until it touches that concrete, and then the concrete allows that force to transfer out to the casing element, which is the restraining element of a buckling restraint brace, and it forces the core to not be able to just bend like that thin wire would. And so it essentially forces the core into this, when it's in compression, into very high mode buckling, and the core then just yields like it does when it stretches. It's yielding in tension. Now it's just yielding in compression, and it makes it much stronger without increasing the tensile strength. So the tensile strength and the compressive strength become the same.
Okay, very good. So there's the way these are built and the way that's poured in there, there's something that prevents that concrete from bonding to the steel, that core plate, so that it does have the freedom to move within there, correct?
That's right. Not only prevents it from bonding, but actually holds it off a very precise different distance. And in each different BRB design, depending on how big it is and how long it is, we have to have a different little gap that's left in there to provide enough space, but not too much space.
Okay.
It's a very tight tolerance on that we have to kind of hold that to.
Okay, very good.
The next slide shows a kind of a blow up, a really simplified blow up of that corner connection with a beam and column that's shown here in blue. And this beam and column is designed by the engineer. It's on the contract documents. It's detailed and fabricated and erected by the structural steel detailing and fabrication team that's handling all the rest of the steel, structural steel in the structure. So that's the common stuff. That's what we all know every day. The BRB then is shown here in red. It's designed and detailed and fabricated by the BRB manufacturer, by CoreBrace. And so that's now a second team that's all of a sudden involved in a big structural steel element. So you then got the gusset plate that becomes this kind of interface component. It still gets designed by CoreBrace, but it's detailed and fabricated by the structural steel detailer and fabrication team, and that getting that element right then is what becomes, I don't want to say the challenge, because we do it, and you guys know this as well, we do it very successfully and very commonly, on routinely, I guess is the word, but it is an element that has to then interface these two teams, really three with the engineer of record, getting everything together to fit, so that when the structural steel erector puts this all up, all these pieces kind of fit together. And so this in the past, and I'm sure in the future, but in the past it's taken some coordination between the groups that, like I said, we've gotten reasonably good at, to make sure that we can get the two elements to fit together properly. And so there's some back and forth that we have to go through to make sure that's right. And what we're going to be talking about today then is then how to streamline this and kind of make it a little more efficient and maybe a little more straightforward for the structural steel detailer.
Okay, very good, Brant. That was good stuff there. So I'm going to kind of take over here and describe our workflow that we would take today or in the past as a detailer, SDS2 detailer, working with a CoreBrace on this. So as Brant explained, he kind of explained what CoreBrace designs and who's responsible for what in that previous slide. So they've always traditionally provided the detailer with that design of the CoreBrace and the gusset plate, any stiffeners or doublers that are required. So they're doing that through drawings, through Excel spreadsheets, and then the detailer is manually laying out these gussets in SDS2. They're manually adding the stiffeners, holes, bolts, welds, all that based on the drawings and the spreadsheets that they get. Can be pretty labor intensive to set some of these up. You know, there is some repetition where you can copy from one to another, or maybe create assemblies in SDS2 to load up. But we did see the opportunity to make this a lot easier for us. And then we talked about there's a lot of back and forth coordination through RFIs, changes to the design, field issues that might come up, different things like that. So labor intensive, a lot of back and forth here in the past with this. If anybody's worked on a project that had CoreBrace in it, they're familiar with what I'm showing here. If you've not worked on a CoreBrace project, this is an example of the Excel spreadsheet that they would typically provide for you. So there's a ton of information in here to kind of filter through to find what you need. They do have it organized pretty logically, but there is also additional information in here that's not really relevant to the detailer when they're laying these things out. So you kind of have to filter through those as a detailer and find the information that you really need and get. So what we're doing here now is we're taking all this information, and CoreBrace can now provide you with an additional text file, just a simple comma delimited text file with that Excel information, and SDS2 is going to read that. So CoreBrace still does the design like we saw on that slide previously. They'll still provide the drawings, the spreadsheets, but we get that additional text file. And as we add these CoreBrace members into SDS2, they're going to go ahead and just simply read that text file, create the gusset, all the holes, bolts. That'll include stiffeners as well in columns or at the gussets if they're required, and create that all for us. So eliminates a ton of that layout. Should eliminate a lot of that back and forth coordination, fewer RFIs, which hopefully translates into fewer field issues. That text file can be updated to reflect changes as well. So really should streamline this process, make it a lot smoother for us. I'm going to get into a demonstration of what this looks like. It can be pretty high level. We'll get down into some details here, but fairly high level stuff. If you do have any questions, there is the question pane on the side of your GoToWebinar toolbar. I'll go ahead and I'm not going to answer any questions as we go along, but once we're done with this demonstration here, I'll have a look at those, and Brant and I will answer those questions to the best of our ability at the end here. So I just have a basic model just to kind of show us how all this works. And what I'm first going to do here is I'm going to turn on what we call a reference drawing just to give you an idea of what the final product might be. So this is a 2D drawing. Typically not going to get anything this detailed from anybody, but you could use, you know, the EOR's design drawings to help lay out or just reference where things are to be located, sizes, what's going where type of thing. So just to give you an idea, we're going to end up with 4 different core braces here on this grid line. And before I add these, there is some setup information that goes along with this. So I can find that in my job options under my plugin options. So these are plugins to SDS2. So we have a CoreBrace member and we have a CoreBrace component. All the setup is going to be related or relevant to the member. So I hit the member here, and I can grab CoreBrace from this screen, and we see in here, so the first thing up at the top I'm going to see is our import file. So this is going to be that text file that's provided to you from CoreBrace. So I have a text file, again, from CoreBrace. It's specific to this project. They have provided that to us. So I'll grab that there. Tells me when it was loaded, and some different information in here that we'll get into a little bit. But the other thing I can do is set, you know, the default grades for the gussets, for the stiffeners, for the bolts. So in this case, maybe I need TC bolts rather than just the regular hex head. So I'll grab my F2280 SC. And then we have a clip on the corner of our plates that we can adjust a little bit. I'm going to adjust that default plate clip size to 1 inch. And the rest we'll talk about as we go a little bit here. So my setup looks good. Now the other thing I need, since these are plugins, we might need to add this a button to our toolbars, or we could find this under our member add prompt within SDS2. I'm going to go ahead and add a couple buttons to my toolbars for us here. So under my model member, I should have a CoreBrace, and there we go right here. So I'm going to add the larger size icon to my floating toolbar here. And then we also have a component. So the component side of this is what will actually add the connections to the end of our braces. Okay, so I have that. I can save that off if I want. And I'm going to go ahead and I'm going to do some additional layout. So everything's going to run from half nominal depth of our beams. So I'm just doing construction line add material here to get a couple of those layout points. And then I'll hit the CoreBrace member. And an important thing to note here is we do want to start at the low end of our brace for our first point, and our high end of our brace needs to be our second point. Reason for that is that's the way that CoreBrace designs and lays out their gussets, and so we want to follow that. We need to match that in order for all these plugins to get you the correct result that you need. So this is our edit window. We can see some basic information. A lot of this is read-only. As you can see, this is information that comes from that text file that you can reference to. One thing we do have to specify in here is the location of this brace. So what we're doing is we're specifying the grid line that it's on, the 2 grids that it's between, and then what level it's on. So in this case, I'm on grid line 1. between grids A and B, and I'm on the ground level. So that's my first option. You probably saw a bunch of these values update, so it read that text file to get these values. We can see my options down here for the bottom end and the top end of my brace have updated. So we have our different grades and bolts in there. I'm gonna go ahead and hit OK, show us what we got. And there we go. So added that brace here, we get all of our welds. You can see we get that 1-inch plate clip at the bottom. This works whether we have a single row of bolts or a double row of bolts there at the gusset. And we also notice that this plate is attached to that column as it should be. For the brace itself is pretty accurate according to the information in that text file. Since CoreBrace is doing the design on this and the fabrication, everything like that, the structural detailer is not responsible for any part of this. What we do is this member is actually set to an existing member by default. So we do that so that it's hidden from your detailing lists and such by default. You don't clutter up with details and that type of thing. So we'll leave that part of things to CoreBrace. And I'm just going to go ahead and add that again. So I'll add my second brace here between grids B and C. Again, I want to work from the bottom end to the top end as I pick my points so that we follow their layout. I need to pick my member location again. So this time we're grid line 1, B to C, ground level. Information updated. You know, I can change the bolt grades and the plate clips on the fly here if I need. In this case, I'm going with the defaults. So, and I'm just going to go ahead and get all 4 of these braces added in here. Remember to set that member location. So this time we're grid line 1, A to B, level 2. So we do have a sloping kind of roof here on this. And after I select this, grid line 1, B to C, level 2. So we will notice a couple of things here. You know, we are typically always working under time constraints and everything like that. So currently we have developed the bolted, and Brant, you can correct me if I get the terms wrong here, but we've worked on the bolted type connection for CoreBrace, and we'll kind of have some additional phases where we implement their welded connection as well as the pinned. I believe pinned is the term you refer to it as. There will be some probably additional enhancements and adjustments as we go here. One thing you'll notice here, you probably see is at our sloped beams, we do have to watch for that and account for that. So in that particular case, I should be able to come in here and do an exact fit on that and get what I need. Of course, if you're a SDS2 user, you're already familiar that will make this component what we call graphical. So if there's any updates or changes to that, you know, we're going to have to be aware of that there, that we're doing graphical. So the other thing that you probably want to be aware of is, you know, typically what this plugin is going to do is kind of find the first member that we're framing to here and attach those gusset plates to that, so we can see at our beam to column connections here, those gussets are attached to the column. Well, in order to aid in erection, make things easier to fit up in the field, we might want those attached to our beams instead of the column. We do have control over that, so I'm just seeing here in my pop out, this is member number 6. So I can actually edit these components, and I can change the supporting member to member number 6. It's going to reprocess those, but now we should see those are going to be attached to our beam rather than our column. So if I highlight that beam now, we can see that switch there, so they'll be attached and detailed with that beam now. And I can do the same thing over here. I believe this is member number 7. So we make that change, and I can do that, you know, anywhere where there's multiple members that we're framing to. So I could do that up in this corner as well. You know, in that particular case, maybe I want to leave it with the column, or I could switch it over to the beam as well. So we do have that flexibility. I'm just going to move over to grid 2 here, and I'll add a couple braces here. So we have kind of a chevron situation here that I'll add in. So we'll go to the center of that beam, and what we're going to end up with in this case is we'll actually end up with a shared gusset plate. So it will look a little funny here for the first one because we only get half of that, but as we complete our model and model that in, it's going to combine that and recognize that it needs to be shared so that we get our one plate, the shared gusset. And you'll also notice on this particular one, if I rotate for us here, I'm going to go back to one tile. Okay, so a little bigger. You'll notice on this one, we do get that stiffener added for us. So that was information, again, that came from that text file provided by CoreBrace. It had a stiffener information in there. So we do get that at that gusset plate. You probably noticed inside of our edit window, we do have some additional options to change in here. So we talked about the grades, the plate clip, you know, that's the corner clip on there. So I could change that to a 1/2 inch. Then we have our weld setbacks. So LWB typically refers to or references the weld to the beam or to the base plate, and then our LWC is information to the column. So it's the weld left setback to the beam. So if I want to hold that weld back to the beam, I can do so, or in this case to the base plate. So when I do that, we should see a update to the clip size, and then our weld's going to be, so our clip size is a little smaller there now, and our welds are held back from that. And again, you probably saw all those fields are available in the setup, so you can change that by default. The other thing to be aware of here is when I do make those changes, we have our information as far as the weld length and the plate length. Right here, that's our LGB and LWBR fields. That's calculated based on the values given and how the geometry works out. Up above, we do have a minimum weld length provided by CoreBrace. So whatever adjustments we make down here is fine, but we just have to make sure that they meet the minimum requirements specified by CoreBrace here. And if I didn't, those fields would highlight magenta for me and indicate to me that, hey, we're not meeting the requirements set forth by CoreBrace. So be aware of that. And, you know, final thing here before I hop in, you know, detailing treats these gussets just the same as it does a typical gusset plate on a column or on a beam. And I'm just going to add a couple more braces here to show us a couple more examples of how things work here. Then I'll detail one up quick just to give you an idea of what things look like. So really the only difference that we're going to see here in this particular case is we're going to see some stiffeners get added to our supporting columns. So in this case, I'm grid line A. And as that gets created, we should see at the bottom of our gusset now, we notice that stiffener is placed in there. So let me add this second one. And again, we'll see that information in there. We're grid line A, 1 to 2, level 2. So there we can see those stiffeners are added automatically along with that. So it saves us a ton of work, ton of time. You know, maybe I'll just detail one of these up just to give us an idea of what that looks like. Okay. Taking it a minute here. I could also detail one of these beams while we're waiting. I'm going to turn off an option here. So this beam here went ahead and detailed up. So this is how a typical kind of gusset plate is going to get detailed. You know, we've got our non-standard hole sizes, all that called out for us. Not quite sure what's going on with that column, why it's taken so long, but it should come up here soon. We also have developed detailing templates for this, so looks slightly different, but very similar result to what we're seeing here. So there we go, there went my column. Okay, so that's what we get on the column side. Probably a little bit of cleanup there depending on your shot preferences and that, but we get the idea of what we'll actually see there. So like I said, that's kind of high level look, but gives us a real good idea of what we're working with, the capabilities that we have. If you do have questions, like I said, there is that questions pane over on the right-hand side there in your go-to webinar toolbar. I'll kind of look at some of these questions here, and Brant and I will do our best to answer those as we can. Before I do, I should also mention, if I go back to our PowerPoint slide, a lot of you probably wonder, how do I get this stuff? Where are these tools at? So we recently came out with what we call an SDS2 toolbox. So this is just an area on our website of different plugins and tools we've developed for SDS2 that you as current SDS2 users can go to. You can download that information. You do have to be up to date on your maintenance fees or a subscription. And you can download, there's a bunch of different tools on there, but CoreBrace will be one of those tools that you can download then. So if you have any problems from there, questions as you get into that and installing them, definitely reach out to us and let us know. So here's a question is, what is the BRB acronym, Brant?
It stands for buckling restrained brace. So you've got a brace, and then you've got that restraining mechanism that keeps it from buckling or forces it to very, very high mode buckling. But briefly, what it means is that instead of a brace in compression being controlled, its failure being controlled by buckling of the member, that has been removed, and so now it's controlled by yielding of the member, which is what we want.
Okay. So another question here is, any settings need to be modified after installing the CoreBrace plugin for it to appear in toolbar configuration? So yep, like I showed, kind of demonstrated there at the beginning when I first got into SDS2, you can add those buttons to your toolbar to fire that. Otherwise, you should also see in my member type selection, in this case I hit F2, we should see a CoreBrace inside our member types to add. So if you prefer doing things that way, you can do that. Also in the component add screen is our CoreBrace connection component. You noticed as I added those and specified the location, that CoreBrace connection was added automatically for me. So this isn't necessarily something I should have to add on its own. It's kind of added along with that member. So does it work in imperial and metric models? Yeah, I would expect things to work in imperial or metric. Can you use the mirror image command? So you could use the mirror image command to, you know, maybe if you added one brace, you wanted to do a copy mirror, you can do that. However, the problem with that is when you do that, your member location is not going to be updated properly. So you would still have to go back in to each member and specify its location still. So can use that, but you know, not necessarily going to save you a bunch of time because you still have to go back and touch each one of those to figure out the member location. Here's another good question. So is there a way to place one gusset on the column and the other on the beam on the top flange? So yes, that's certainly doable. So when I did this, what I actually did was I did what we call a multi-edit on these components. I attached them both, but we could just leave this one here. So maybe we want this top gusset to be on our column. We can do that as well. Any combination will work there. Each of those connection components has its own control over which member it's attached to. So flexibility there. So another question here. So this is about CoreBrace fabricating the BRBs themselves. So since CoreBrace fabricates those BRBs, they do not need to be in the fabricator's BOM. Would that typically be correct, Brant? That's what I would expect.
Yeah, absolutely.
Yep.
The gusset plate designed by us, but would certainly be in the fabricator's bill of material, and the brace itself is going to get delivered to the site from us and just erected.
Okay, perfect. So another SDS2 related question is there an option to have the gusset shipped loose or not connected to the column or beam? In that particular case, we don't have that built into the member or the component. In that particular case, you would resort back to, you know, doing a break member apart command in order to break that apart. So. Question about the weight of the CoreBrace that's reported, if that includes the concrete inside. That does not include the weight of the concrete inside of there. So we don't actually add any material inside of that brace. You can see here what we're doing is we're really just representing, you know, the one plate that goes all the full length to connect the two gussets like Brant described earlier, and then we give you the two lugs as well. So we don't actually put the concrete material in the model for that, so it wouldn't necessarily be accurate there. Sorry, go ahead, Brant.
In the tables that would be in the CoreBrace drawings, that weight with the concrete is given. So if you needed to provide that for some reason, it would be there in the drawings. It's just not calculated in here.
Okay, very good. And you know, one of our main goals that we wanted to do here was we really wanted to represent the lugs and the gussets and everything accurately for kind of clash detection purposes, to make sure there wasn't going to be any piping or anything like that that could potentially interfere with either CoreBrace or the gussets. Base plates update based on the required weld length. The base plates do not update based on that information. These particular gusset plate, or excuse me, base plates, those are just coming from our typical base plate schedule like we would typically use, or could be a user-defined connection or whatever. So that's what we're seeing there.
And Dave, let me add to both this question and the previous one where you're mentioning clashes. A lot of what we're doing here is trying to point out if CoreBrace has understood something differently than the SDS2 detailer. And so if that gusset plate is too long for the base plate, for example, or if you're seeing a clash where that lug rides over onto the weld or something, as opposed to just making that fix or automatically update, we want that to show as an error so that you can kind of flag that location, maybe go on to others, but go back to CoreBrace and say, hey, this brace you're planning to build is going to cause me problems. What do we need to do? And we might need to taper that base plate so that it fits onto the gusset, which would change perhaps the weld size or something. And this gives us kind of a heads up and alerts us we need to fix that location, and we need CoreBrace to potentially provide a shorter or longer brace as well to fix that issue, so that they don't get something to the site that won't fit what you've potentially a fix that you've had to make, but which the brace wasn't adjusted for.
Okay, good info. Couple other questions here. So will the BRB connections on work on beams that have failed connections? So yeah, these aren't like your typical kind of built-in vertical brace. This is completely outside the scope of SDS2's connection design. We're just simply taking the information that's provided by CoreBrace to create these gusset plates. So beams with failed connections are not going to affect this at all. And here's a question for you, Brant. Good question. How does CoreBrace back check or verify the gussets done by the detailer to verify that they followed your design? Do you have a method kind of internally that you do there to verify that?
That's a great question, and we do. We essentially will usually get, similar to the detailed drawings you showed a minute ago, we will usually receive back we refer to it as a layout drawing, but it's that full frame that shows the bolt pattern information, the weld sizes and length, the gusset plate thickness, and then very important on that shows the length of the brace from the outer two most bolt holes. And so that lets us confirm that, yeah, that the information has been properly interpreted by the detailer, and that they're accounting for the same brace length that we're planning to build. So we do go through and check all of those, and that is one of those things I mentioned. It's a little bit of effort, but it's extremely valuable to make sure everything's going to fit up. And when we go through that process, we'll almost never have an issue with a fit up. We can confirm that you're planning on the same length of brace to fit in your frame opening that we're planning to build, and it eliminates most of the issues. This speeds up the effort of detailing tremendously. And then you produce that layout drawing, send it to us. We'll kind of put a second set of eyes on it and confirm that we agree with it and what we're planning to build fits that.
Okay. So I think we'll grab a couple more here, and then we're getting a little long for what we wanted today, but I'll get to a few more questions here. So there's a question on how does CoreBrace know what distances SDS2 is giving to clear the column and beam? And I assume you're kind of referring in that particular case. I would assume you can refer to a couple things here. So first off, you can refer that to the lug that we have here. And again, that's done on CoreBrace's end with the design. So you actually know that, or should know that, before that even gets to the detailer, I would assume. Is that right, Brant?
Yeah, so we've designed, and we do all our design checks on these gussets to make sure they're going to remain stable and stuff. We're assuming some clearance that might be the weld size plus an inch or something. We've designed around that and confirmed that it fits. The reason you then have to pick the bottom work point and the top work point is it throws a brace in of a given length in that space, And if you, for example, right there, if that lug plate was riding over on that well, that would be an example, like I mentioned earlier, where we had misunderstood something, and you'd come back to us and say, you don't have a clearance here, but ultimately that clearance has, like David said, been set by us, and it's not critical. If we thought it was an inch and it's really, you know, 0.9 inches, fair enough. If it clears it, unless the contract drawings, you know, stated something specific otherwise. But if it's dramatically different or you're getting a clash, then we've misunderstood something, and that's where we would come back and say, hey, why are we not getting the same answer here than you are? Why are we showing a clash? And we would update and allow for a shorter brace, or find out that the column was maybe a different, you know, depth than we thought or something, and fix that error. But that spacing is set by us, and then you can see that spacing. It's on our drawings. You could confirm what that is, but it's set by us, and it's not an input that the SDS2 user has to set.
And the other clearance or variable in this case may be this clip on the plate. So that's up to the detailer fabricator. They do have flexibility to adjust that clip size, so long as adjusting that clip size still allows the correct minimums, or at least meets CoreBrace's minimum weld lengths and such. So there is some freedom there on that, but we still have to meet the CoreBrace design requirements.
And the gusset, for example, if you're freehanding one of these gussets, what a lot of you guys have done in the past before this plugin's available, you know, you can extend the little the little clearance on the diagonal at the far end of the gusset there, right before you get to the free edge. You could extend that a little bit so that the gusset ran a little longer onto the beam, or ran a little longer onto the column, to pick up some weld length if you need to. On the vast majority of jobs, that's set to be 1 inch minimum, but you could push that to 1.5 inches or something if you needed to pick up a little extra weld length to accommodate a larger clip or something.
Mm-hmm. So another question here is about detailing a CoreBrace. So again, we're the CoreBrace detailing, design, fabrication, that's all left up to CoreBrace. So we're really not detailing that or providing any drawings for this member in SDS2. That's on them. They already have their own tools implemented to do that. So we're not really doing that here within SDS2. Another option, or excuse me, question. We're kind of running out of time here, but our CoreBrace, is this specific to a version of SDS2? So you will be required to be in SDS2 version 2020 or higher. So yeah, you do need to be in at least SDS2 2020 for this to work. So I realize there are a few other questions here. Some of them are a little off topic, so I'm not going to answer necessarily all of those here today. We're going to kind of cut it off here as we're getting pretty long. I will look through some of those other questions and get to some of those unrelated topics and such through email, answer those best I can here after the webinar. But just want to remind everybody, so that SDS2 toolbox on our website, that's how we're going to get all these plugins, so check that out. And yeah, if anybody has anything else, reach out to myself. Brant is a good resource on the CoreBrace side of things if you have questions specific to how CoreBrace works, and we'll do our best to get those answered. So thanks everybody again. I appreciate your time today, and yeah, looking forward to the next time when we can maybe all be in person after the Rona. So thanks again.